Hello class, I'm working out of your geometry book 4.1, angles in triangles. Look at the chart on page 148. Those charts review acute, right, and obtuse angles, as well as scalene, isosceles, and equilateral triangles. Remember, a line is 180 degrees. Also, in a triangle, the angles of the triangle add together to be 180 degrees. So knowing that, we can run some algebra to figure for missing angles. For instance, if we have an angle of x degrees, but we're given the other two angles degrees, such as in this triangle, we can add all the angles together and set them equal to 180 and solve for x. 52 plus 48 is 100 plus x equals 180. Subtract 100 from both sides. This goes away. And we have x is equal to 180 minus 100. The remaining angle is 80 degrees. In another example, if you are given a triangle that looks like this, you have an external degree angle, but inside you're given angles of 1, 2, and 21 degrees. You can still find out how many degrees each angle that is missing is, knowing that angle 2 and 72 degrees in this example is a linear pair. They're supplementary angles, and we have already looked at solving for that. So if angle 2 plus the 72 degree angle is equal to a line as a linear pair, then we can solve for the measure of angle 2 right away. We have the measure of angle 2 is equal to 108 degrees. Okay, so we know the measure of angle 2 and we know 21 degrees. We still can solve for the measure of angle 1 here. So to do that, we say the measure of angle 2 is 108 degrees. The remaining angle given is 21 degrees, and we have the measure of angle 1 is unknown, all set equal to 180. This is renamed as 129, where 108 plus 21 plus the measure of angle 1 equal to 180 minus 129. And we have the measure of angle 1 is equal to 51 degrees. And we have solved for all the missing angles in this example. Next, If you are given a situation that looks like this, we know this is a right triangle, and in a right triangle, the highlighted angle is 90 degrees. So algebraically, we work the information and solve for x in the same way we have been doing the solving for the missing angles. We just have x variables thrown into this. Don't let this throw you off. We still have the interior angles of a triangle are equal to 180 degrees. So in this situation, we'll say, okay, 2x plus x plus 90 is still equal to 180. Subtract 90 from both sides. And we would have 2x plus x. Well, that's 3x is equal to 180 minus 90. And we see that we can solve for x very easily now. X is equal to 90 divided by 3. So we have x is equal to 30 degrees. Now we're not done because we've only found the measure of the angle of x degrees. There is still an angle missing, and that is 2x. So working above 2, substituting 30, and for the missing angle, we would have 60 degrees. So 60 degrees, 30 degrees, 90 degrees. Don't forget to go back and substitute for your variable in these situations where we still have a missing angle that is not calculated. Okay, in our last example, if you are given a situation like this, and we see angles 1, 2, 3, and then we have some degrees given to us. That's supposed to be a 36 up here. We can calculate for all the missing angles. Let's do that. To begin, select one triangle. The best one to select is the one that has the most information. We have two given angles in degrees and a missing angle, the measure of angle 1. Start there. So to start there, we would say 36 degrees plus 60 degrees plus the measure of angle 1 is equal to 180. We solve. Rename 36 plus 60 as 96 degrees plus the measure of angle 1 equals 180. Subtract 96 from both sides. This goes away. So we have the measure of angle 1 equals 180 minus 96 is 84 degrees. That's one of our missing angles. Now we know the measure of angle 1, and we know the measures of angle 1 and 2 are linear pairs. They're supplementary. That means that they are also equal to 180 degrees on the line. So if that is true, then very simply, we can add the measures of angle 1 and the measures of angle 2 and set them equal to 180 to solve. We have the measure of angle 1. We just solve for it. So, knowing the measure of angle 1 plus the measure of angle 2 is equal to 180. We continue to solve. The measure of angle 2 will now be equal to 96 degrees. This leaves the measure of angle 3, and now we know the measure of angle 2 plus 45 degrees, 96 degrees plus 45 degrees plus the measure of angle 3 equals 180, and the triangle angles all together. Again, we solve. Rename this as 141. We keep solving. The measure of angle 3 is 180 minus 141, excuse me. And your answer is 39 degrees. Now we've solved for the measure of angle 1, 2, and 3, knowing that the interior measures of a triangle are equal to 180 degrees, and thinking about a line is also equal to 180 degrees in the linear pair because those angles are supplementary. Read all your definitions, corollaries, proof examples, and theorems on pages 148 to 151. Go over these examples, and I hope this helps. I'll see you soon.